This is the initial screen of Smart Balancer Echo, where you find various options. Now we are going to carry out one plane balancing. We have connected an accelerometer cable to channel 1 and sensor is mounted at suitable position. We have placed a reflecting tape at point. This one is taken as 0 degree normally. Now we start. We go in the reference RPM sensor. Remember that RPM must remain constant during balancing run. So this reference utility is to give a direct interface to the input derived from reference sensor. It gives RPM measurement of the rotor. Now we go in balancing one plane. This is the setup. Channel 1. Normally we take a single plane rotor head if more than 7 to 10 times of its width. Now we start the initial run, which shows the phase vector, amplitude and angle of the measured signal and the RMS velocity. Actually amplitude is the highest peak value and angle is the phase difference between the trigger level and the highest peak. Now we pause. Simultaneously we have to stop the machine. Now we have completed the initial run. We go to the next screen where we have to mount a trial mass of the suitable size arbitrarily in the correction circle. That is the phase where correction is to be made. Now we add suitable mass, that mass at an angle of 0 degree, 20 kg, and we have to mark the position of the trial mass as well. We are going to add a mass of 20 kg as 0 degree, where we have placed the reflecting tape. We have taken it as 0 degree. Now we go to next screen where this is trial run. Again it will show the value. Now start the machine and then proceed here also, where trial run will be taken, and again the phase vector, amplitude and angle of the measured signal will be displayed. General approach is that test mass has generate a force which is equal to 0.1 times of the weight of the rotor. With this relationship, vector moves suitably. Now we pause and go to next screen. Here it says, do you want to remove the test mass? If I say no, I am not going to remove the test mass. Now stop the rotor. We are not going to remove the mass that we had already added in previous step. As suggested by our instrument Smart Balancer Echo, the mass of 17.22 gram at 192 degree. So we are going to search this 192 degree over the rotor. We have taken 20 gram. Now we will add this 20 gram at the position in the vicinity of that 172 degree. Let us take it as 180 degree. This 5 is taken as 180 degree, which is marked as 5. This is 180 degree because we have divided the rotor into 8 parts. Now start the rotor. Now we have added correction mass and go to the check round 1, where we will show the amplitude and phase. It adjusts the range and vector try to move towards the center. It means you are trying to achieve the balancing rate. Under balance state, this vector should reach as the center. Now we will move to next screen where the residual unbalance is 4.1 gram. We have to save, and then you can repeat the balancing option so that you can reroute the finish session from the memory of the Smart Balancer and do the new balancing at the machine being already balanced in the past without need to do test run. This is the advantage of saving the file, and you can start from there only.